Hello everyone, my name is Nawaf. This is my teammate Sean, Faisal and Ahmed. Today we're going to talk about CO2 injection in oil industry as secondary method recovery. Due to increased importance of crude oil to meet our energy demand, more innovative method and process are now used to its extraction. Oil production has been classified into three main phases, which are primary, secondary and tertiary. Secondary method recovery is used when primary method is no longer available and can produce 40% more productive recovery than primary. This method includes the injection of CO2 in well-containing oil droplets, which then forms an oil mixture that bumped into the surface by producing well. Half of CO2 injected can be recovered by using a process like adsorption. This method is feasible and particularly effective in reservoirs that deeper than 2,000 foot. This picture explains the WAG. It's injection water with CO2 to create a miscible zone, and that process called WAG. This process increase the productivity of oil in the well. This process happened because the water decreased the viscosity of oil and increased the efficiency of miscible zone. There are some factors affecting this process, like depth of the reservoir affecting the temperature and pressure, and hence the physical characteristic of CO2 gas. And the other one is oil composition and its gravity, site-specific thickness, porosity, and the probability value of the reservoir, oil and water saturation that affect the miscibility of CO2 gas. This process is simple and economical because the CO2 as a solvent is cheaper than other miscible lower hydrocarbon solvents. This process has some merits, and one of them is environment beneficial if the industrial CO2 is captured and stored in the reservoir. Low cost due to the abundance of gas, low mutual solubility of water, and low minimum miscibility pressure, and high miscibility of oil. And there are some demerits. One of them is corrosion. One of them is corrosion of facility. Great well spacing required that reduce sweep efficiency. Plugging due asphalting and precipitation. CO2 removal from the production well is costly, and CO2 within the flooded area. As some CO2 will leak off to pressure sinks beyond the lease line, the losses are typically within the flooded zone, but several projects due to vertical losses have resulted poor utilization of CO2 and can lead to an economical failure. USA leads the world using this method for oil extraction. The process was first employed in Texas during 1970s and then in New Mexico. Petronova and Kemper project are famous one. Similarly, in Canada, Weber Midale is currently using CO2 injection method extract oil, which is supposed to be the largest CO2 storage wells. And Sean will talk about the case.
Okay, so our case study took place in the Eagle Ford Basin. The Eagle Ford Basin covers a large area in southern Texas. It's composed of two lateral sections, namely the upper and lower, and both of them are pretty laterally continuous, which is good for us. And it has proved itself in the past 7 years as a pretty viable reservoir because it's produced 2 million barrels of oil. This case was done mainly because there's not that many field studies that have been conducted. There's a lot of lab studies, but field-wise, they needed some more. And I'm going to cover 4 of the case studies that were done out of 7. So, for Pilot A, it was pretty basic field test. It was one well. It was 2 miles away from the nearest producing well, mainly to keep any gas that was injected from migrating and skewing any data or results. and they use the huff and puff gas method, which we've talked about several times. So it just they cycled gas every time the rate would drop below a certain point, and it seemed that their results proved that each cycle that they had would increase the production by half of the initial rate that they had before injection. So for pilots B and C, they were both multi-well plots, with half of them being producers and half of them being injectors. This was done to see the influence on the producers from the injectors, so it's basically the opposite of what they did the first time, and it did yield a positive result. Now I'll cover a little bit into Pilot B specifics. So Pilot B had 4 injectors and 4 producers, and the way their pattern was set up is there was 4 injectors in the middle, and then on either side they had producers. So they injected for 1.5 years and then put it on production for another year, and then that increased production during the injection by 17% of the initial rate. For Pilot C, this one had 8 horizontal wells and wells positioned at the heel and toe of all of those. And the way that they had it set up was the interior 6 were injectors, and everything that surrounded them would be the producers that they would monitor. And it was also designed to show the influence on the producers, like Pilot B. And it was injected for 2.5 years and yielded a 20% increase in production. And for Pilot D, it included 4 wells. And this was even more isolated than the first pilot. The nearest wells were 100 miles away, and it was southwest of the A, B, and C pilots. The way they did it, they injected with the huff and puff method on all 4 wells simultaneously for 3 years straight, and the production actually doubled as a result of this. And because it had such good isolation, it yielded very good results and data, so nothing was going to be skewed. They knew exactly that this was as a result of what they were doing. And they've created a lot of plots to predict future recovery methods, and a lot of the plots estimate that 50% more than the original production that was predicted is going to be produced. So this graph shows the pilot test. So the purple line is just the base primary production from the multi-plot wells. The little blue line and the little black dotted line are pilots B and C, and then the green is Pilot D. So they extrapolated it out to show you how it would increase in the next however many years you want to take it. So it's a pretty good increase. You can go next. For the future considerations of pilot tests, the best thing to consider would be like how you're going to acquire the gas. So, I mean, you got to play in factors of cost, transportation, and everything. And then solo ventures with operators is better because they have more say in what goes on. They can make better decisions that way. And it seemed like whenever they did the isolating of wells, they yielded much better results. So that's another key factor for future consideration. And complex fracture systems are usually pretty necessary. That allows the gas to migrate more easily through the reservoir. And field tests tend to yield better results than lab tests do. So that's all I have for that.
Thanks, Sean. So I'm here to talk about the viability historical background, often referred as an enhanced oil recovery second recovery technique has been used for a long period. It has almost the most commonly used technique in curing oil around the world. It used to recover oil left after the primary extractions method. It is estimated that the technique can facilitate the recovery for up to 30 and 60% of the original crude oil. The chart on the right indicates the possible oil's production outputs in different technologies, as you see in millions gallons. Another name of the approach is miscible flooding method, since it involves injection of miscible gases such as carbon dioxide into the primary exploited well. The process leverages the interfacials difference between the oil and water and to separate the two fluids. The process tries to maintain the temperature, the structure configuration, and the pressure of the oil reservoirs in a temperature manner to improve and create a good environment for the extraction process. AUR through injection of carbon dioxide into the oil wells is advantageous because it maximizes the oil production by increasing the reservoir pressure. In steps regards of the existing condition of reservoir. In exploitations of natural gas, the process stabilizes carbon dioxide and methane by facilitating formation of chelate or immediate stable compounds, so that the carbon dioxide has no longer accessible with other compounds to form other undesirable reactions. This process is referred as net segregation. It enhances cumulative recovery of natural gas as well as other desirable gases. It is a good way to sequester or remove the carbon dioxide emitted from the atmosphere. A good example of that advantage of carbon dioxide injection during AUR is 2002 carbon dioxide flood accounts in the United States of America, which reduced to 28% of the total AUR production and in turn represent the 3.3% of the average total crude oil. Of the various forms of carbon injection method, swag inoculation paired with carbon dioxide, injection rate of 15,000, and swag ratio of 1:1 is the most efficient one because it has a high yields recovery factor of 50%. A water minimization below 0.9 and relatively low carbon dioxide quantum leap. However, the technique has some disadvantages since carbon dioxide is not readily available and difficult to obtain. The carbon dioxide injection process is also expensive because carbon dioxide used for AUR naturally exported from the underground carbon dioxide reservoirs and later transported to oil extraction plants. Even though people may think that the process can eliminate carbon dioxide emitted by industries, the process has a positive balance on carbon dioxide, since it leads to exploitations of extra oil that couldn't have been introduced into the market through the primary extraction process. As such, the amount of carbon dioxide by the process is relatively less than the released by the consumption of extra oil. Carbon dioxide is also portable. Besides, since carbon dioxide has lower density and viscosity compared to crude oil. Moreover, carbon dioxide injection AUR is highly hazardous. There are high risk of fires, explosions due to the flammable vapors from tanks, production equipment trucks, and wells. However, identification and elimination of ignition resources prior to the process can greatly reduce the hazards. Gas monitors can also be used to prevent onset of fires and explosions. The technique also exposes workers to respiratory hazards if not properly undertaken. Fumes of hydrogen sulfide and diesel emitted during the AUR can cause suffocations and even death. What?
2 more minutes.
Okay. When to use carbon dioxide to maximize recovery or production in oil reservoir fields, to facilitate cumulative recovery of natural gas and other desirable gases, to exploit inaccessible oil in deeper parts of the oil reservoirs. The last one, to extract some of the oil left after primary extraction process. Why we use carbon dioxide? Inefficient and cost-effective compared to other AUR methods. It serves as an effective method to control environmental pollution from carbon dioxide emissions and facilitates recovery of 30 to 60% of the original crude oil after primary extractions. And it's major technology since it has been in use for many years from now. And now my colleague Ahmed will discuss about the economics.
Today I want to talk about the economics of CO2 injection process. The key factor beyond the economics of CO2 is site area and economic viability. Expenses related to the injection process mainly depend on the area, geologic qualities, conception of the objective field, and the measure of CO2 requirement. After thoroughly studies from different literature, we come to one point that cost of oil and CO2 is critical impact and on the economic viability. It's not during favorability conditions the process become economically modest. Also, it can be also affected or reduced by the mechanical testing, service, and the maintenance addressing. Next. The factor contribution. The major element that contribute to the economics of CO2 injection process are: first one is the well drilling and completion. It's deeply associated with the geological condition of the wells. Second, lease of equipment, in which we have to pay the capital cost of all equipment. Third is the conversion process, which also affect the contribution toward the economy. It's required additional equipment and distribution lines. Fourth, the maintenance cost that will affect the project annually. Fifth, recycling of CO2, very important factor. Also, involvement of new equipment and affect capital cost. Last one, pumping and transportation cost, which may vary throughout the year as per demand and production. In conclusion, the CO2 injection is the most common secondary oil recovery method available. It's a basic working principle in the introduction of carbon dioxide into the reservoir where it's spent. The miscibility zone created by this expansion caused the oil to move into the well where it's later on the drilling out. Also, the process is viable because of the abundance of carbon dioxide gas in the world. A detailed study of reservoir project plans and feasibility reports is required to determine the monetary viability of specific CO2 injections, geological qualities, conception of the objective field, and the measure of CO2 requirements. Thanks.